Try and hide stuff down the bottom as much as I can. All right, so previous sessions we've done the 2D stuff. So where we kind of have a sketch profile from the side, and then we'll go through, make it into a 3D model, and eventually kind of lay it all out for CNC work. This time, we're going to be doing it a little differently, where we don't model individual pieces. We're just going to model a solid object and have some true kind of 3D geometry in there with like a curved surface and slopes instead of just kind of flat panels. So we kind of start it off in the same manner though. We start off creating a sketch, and it's the way I prefer to do stuff because I do a lot of, I guess what you'd call inorganic things. If you have a more organic shape, you can use the surface tools where you would create where you start off with like a form here, cube, and then you'd be able to increase or decrease the kind of segments, and then you can modify that from there with the edit form. You can just kind of move things around, get different shapes. So that's an option if you wanted something a bit more organic, less precise. It's kind of something, call it homework for you to look at. But that's not what we're doing. We're going to be doing the, I guess you'd call it hard body if you've ever done any 3D modeling in Polygon modeling tools. So we start off in our design solid surface section. We're going to create a sketch on the XY plane, basically the floor. And for this, we're just going to kind of start out with a create polygon and just start with a edge polygon. And what we can do with that is kind of just have a, say, a 5-sided shape. No, 4. No, we'll go 5, so it's more interesting. So 5-sided shape, and with the sides being a 2-inch length. So we do that, click Finish Sketch, and then we can see we have a pentagon on the ground. What we actually need to do then is think about the top shape we're going to go for. So we'll have a pentagon up at the top again, and we'll have kind of like stars coming out the sides, like a starfish. So as this is right now, that's okay. There's a couple of different ways you can go about it. Like most things, we can either extrude this upwards by fixed amount, say like 2.5 inches, and say okay to that. So that's E-extrude, and then drag it by how much we want. Then we could then take one of these faces and do an extrude on this. If I undo that, extrude this face, and then we can actually use the taper feature, say maybe minus 30 degrees, to go inwards, like so. Maybe that's a little extreme, let's do minus 10 degrees, so we can get a bit longer. So that's kind of one method of getting a sloped surface on the side of that. As you can see, it's a sloped surface in every direction because the taper works uniformly. So that's one option. And the problem with that is that we won't be able to machine the underside without doing a flip on this. The other way we can do things, if I am to hide this version, so I should open up the bodies tab and hide that. The other way we can do it is with an offset plane. So we would have in the construction offset plane, and we're going to offset it from this face here. And what that's going to do is create an invisible piece of geometry that we can then base our next sketch layer off. So we say we want this to be 2.5 inches up. We can then use this as our sort of drawing surface for our next sketch. And what we can do there is do another create sketch. And basically we're going to project this pentagon onto that by double clicking the rim, and it will kind of select the whole perimeter. Say okay to that. Then if we finish that sketch, we can do a couple of options then. We can either do a create loft. So even though it's just the same shape, that's kind of the way it's working. So we can loft between shapes like that, and a quick cancel. We can also start looking at a sweep between the two faces. Oh no, we can't. We need a path for that to follow. So loft goes between two faces, two shapes. So if we were to edit that second pentagon we made, delete that, and turn it into a 1-inch circle on the top, what we can then do is choose to do a create loft from the bottom to the circle. You can see we kind of get a different profile there now. So we can go between two different shapes with the loft function. And that's kind of when you can start getting into some more interesting geometry. You can see it starts off very kind of straight at the bottom, and then as it gets to the top, it has a true curve of the circle. So that's something we can do with that. What we can also do is this sketch that we have on the bottom. If we come down into the history where we created it, we can double click on that, and it will take us back into that sketch. And we can actually do we double click the rim and press O for offset. We can pull that out so that we can then get our sort of sloped shape. So we offset that by 5 and say okay to that. Say finish sketch there. And I'm going to unhide that on the top. And so we have options here for the circle, the top pentagon, the bottom, and then a larger one. So I'm going to actually double click on this loft at the bottom. And what we'll be doing here is this profile 2. So because we're editing the feature, it has the profiles that we've already created. We want to change profile 1. So we're going to remove that by clicking the little X when it's highlighted. And then we're going to add a new one. And it's going to be this lower profile. And
how did you get to this the edit feature pop-up window?
Yeah. So down at the bottom, in the design history, there's the features. If you double click one of them, then you can edit that feature.
Okay.
It just is easier than kind of deleting it and redoing it again. So you can right click them as well for other options where you would suppress this feature. So the history will still use it, but it is not kind of taken into account with the rendering. So we can double click to edit that and change profile 1 to be that one. Oh, okay. Change profile 1, exit out, and say that we want to use this one. Then we can hide our sketches again. So we have a more interesting kind of shape now, right? Everyone kind of good with that? If anyone wants us to kind of cover anything again, gonna have to unmute and speak up. Gonna assume everything's good then. What else I'm going to do though is just make that circle a little wider at the top, so maybe like 3 inches, and make sure that it is centered there. Or roughly centered. So now we effectively have a 2.5 inch tall shape with a curve at the top, like the whole surface is kind of curved. If we kind of were able to look along that, you can see at the very kind of top there, the surface is following the curve of the circle. And if you look along the side, you can see it's kind of, it bows around. If I select that surface, you can see it's going from a flat surface at the bottom to a bowed kind of hill at the top. So that's kind of one way of making a kind of true 3D object. And now would be a good time, I guess, to cover how we would make this same object if we were to make it out of separate pieces. So we'll go back to our construction planes in that case, and we would get a offset plane. We'll go from the top in this case, I guess, and say we're going to make it out of 3/4 inch lumber. We'll do a offset from the top going downwards, so negative. So negative 0.75 for 3/4 inch lumber. Say okay. And then we can do another offset plane from that one. So same again, negative 0.75. And again, offset plane from there, negative 0.75. And that should give us 3 splits, yeah, leaving the bottom in place. And then what we can do with that is, under modify, we have the option to split something. So we can do split body, excuse me, split body. And we can actually use these construction planes to split the model that we've created. So we'll go to select the body to split. It's going to be the model. The splitting tools are going to be all 3 of these planes, 1, 2, 3. And you can see it makes these big red circles that kind of extend past the outside to make sure it's actually splitting the object. So we click OK on that. And then we can come over here on the left, hide the construction objects. You can see it's been broken down into a couple of different pieces. So they're all separate objects now. And then with those, we would just kind of lay them out the same way we laid out things in previous weeks. I like to use map boards as the plugin. Say a length of, say it's got like a 4-foot board. And it'll lay them out for us as we would want to cut them out. We could actually fit that one in there. So I hope that warning message is not accurate.
Can you show again where you clicked to get those the layers when they were yellow?
Yellow.
Before the red discs.
Like this.
Right. Where did you
So
get that command from?
up here, when we're in the solid, in design solid, under construction, there's offset plane.
Okay.
And you can create a plane at an angle, a plane that's tangential to a curved surface, a bunch of different options, and like an axis through the center.
Which was the one that was used here?
This was just offset plane. So it's offset from an existing surface.
Okay.
And you can do that by distance or to a certain object.
Okay.
So you're going to save that and roll forward in the history. So yeah, I like to use map boards. If you don't want to fork out for that, I think it's $15 for the basic, $25 for the pro, then you can just kind of manually move these by selecting them, pressing M for move, and then laying them out appropriately. But for now, I'm going to rewind in the history, hide the construction, so we'll have this solid object before we split it. And we're going to use this for our manufacture. And then after that, we'll cover how to do it with locating dowels for kind of stacking it as multiple pieces if you can't get hold of, say, like 3-inch thick lumber. Or metal, if you're using metal. So I'm going to switch over from design to manufacture. And just a heads up, guys, if this meeting does expire, then I will post the meeting link in the Slack channel, in general Slack, and also as a comment on the meetup page, in case it ends and everyone kind of gets kicked out. So we're in the manufacture tab, and it's kind of the same as we've done previously with setup. So we just click setup, and the default model is the only body we have. If we didn't have anything, we would just select that. Or if we had more than this object, we'd just select the relevant one. The orientation in this case is fine because it's just, it's just the one object with, it's kind of symmetrical is what I'm saying, rotationally. So the orientation doesn't necessarily matter. If we wanted to kind of orient it a certain way, we'd do it with these options. And that's kind of however the machine's set up for use. So the shopbot is set up with Z, X, and Y. So the important part here is our stock in the setup tab. So we want to make sure our stock is the size we'll be using. Say we have a few pieces of plywood that we've glued up, and they're 18 inches by 18 inches by 18 inches, and then they are 3 inches thick. So we glued up, say, like 4 pieces of plywood. We can then say that the model is actually, you can see here that it's floating off the bottom. We would actually want that to be on the bottom of the surface. So we would do a model position offset from bottom by 0 inches. You can see it kind of moves that to the bottom there. We'll say OK to that. Go into our 3D view again. So what we have here is effectively a block of plywood, a block of 4-piece of plywood, and we would then cut the shape out of it. So as you can imagine, if we were to look from the top, we don't really want to be kind of carving all this triangle out, all this triangle out, you know, the kind of 4 triangles that make up the corners are just sort of wasted space. So we don't really want to be interacting with those with the cutter if we don't need to, because it's just kind of wasted time, wasted cutting. So what we can do there is in our operation, we can do several different steps. So we have a clearing pass, which kind of gets rid of the meat of the material, but not to an accurate dimension. And then we have what you call finishing passes. So you have your roughing pass and your finishing passes. And we'd probably want to do, well, we definitely would want to do a tool change between those in this case, because we have that curved surface. So for that, it would be now I know I said we're doing 3D this time, but that'll be for our finishing pass. I like to do no, actually, I was telling the truth. We're going to do a 3D adaptive clearing. So 3D adaptive clearing. And we will say that we will use a 1/2" cutter. So 1/2" tool. So from there, we can say that we want it to look at the geometry. And this is where things are going to vary up a little bit from where we were at last time. So whereas previously we looked at 2D machining and we would select the outside path for it to kind of machine around, what we're going to be doing here is letting the program kind of figure it out, and from there just going to let it know what we actually want it to cut. So if I say OK to this, it's going to do some calculations, and you'll see it does some counting up here. It's a lot slower because it's thinking, obviously. You'll see the kind of percentage going up here. And as it calculates, it does many layers and kind of roughs out the shape down the slope. I will edit this though so it doesn't keep calculating needlessly. We need to give it some guidance because as you saw there, the stuff that it's cutting out is like way too much, way too far on the edges. It's going to cut into any screws or clamps that we have holding this piece down. It's just no good. So what we need to do is tell it where it can machine. So under here, geometry, we give it a machining boundary. And where it says none, here you go, some good examples here on that screen there. What we're going to do is say that it can actually machine the silhouette. So it's going to look from the top down and see the silhouette of the object that we have, and it's going to cut on the, it's going to either cut on the inside of that silhouette, directly on the border of that silhouette, or a little bit outside of that silhouette. So we're going to want it to go outside so it can get a full kind of, the full effect, I guess you'd call it. So again, it's a tool outside of boundary. And then additional offset, we don't need to give it any. Sometimes you'll get an error because it won't go all the way to the edge, perhaps in a corner. You can just kind of give it an offset of whatever your tool radius is, like 0.5. In this case, I don't think we will need to. And then stock contours, you can see here, it has the yellow border. If we were to have a additional material we wanted to remove, we would kind of choose that. If not, it's usually fine as it is. So we just kind of say the stock contours are fine as they are. Rest machining is something interesting as well. So if we have multiple operations, which we will once we get to the finishing passes, it will actually take into consideration the passes that have happened previously. So you can see here it says rest stands for remaining stock. So taking the first 2 letters of each of those. So the example that it gives is if you were to cut out the little triangle part of that teardrop shape, it would then only cut out the circle part in the next operation instead of cutting out the triangle that's already been cut. So it's kind of a time saver. Usually the settings are kind of good as they are. So from setup source to, I'm going to say ignore cusps, which are basically just little steps that get left. And we're going to want it to be adjusted just by a fraction so that it doesn't bother trying to remachine little tiny parts again. So if we left this as it is and said, okay, it's going to cut all the way down to the bottom, the part's going to come loose, and it'll just be a stair step of this shape without any kind of real, I guess, without any real definition. It would just be ridged, kind of like a Aztec temple, instead of what you traditionally see in like a pyramid kind of shape. But you can see straight away here as well, as it calculates, it's no longer going to the edge of where it was previously with this big square. It's stopping short and only doing the part that it needs to in order to get the shape. So that's the importance of using the machine boundary. So I think that kind of illustrates the point. Again, not going to let it calculate needlessly. So in the next tab, we're going to go on to heights. And in order to keep it secure, we're going to want to make sure that we don't go all the way to the bottom. So we're going to want to leave from the stock bottom, maybe like 1/10 of an inch or 1/8 of an inch, just to kind of hold it in place. If we don't do that, like I said, it's going to kind of just come loose, and then we won't be able to do our finishing pass to smooth it up. It may be fine to do that if you have a shape that doesn't need the precision. You can just kind of do that and sand it flat. But in this case, we're going to be doing some extra ones, so we want to make sure it's still connected to the big square that we have connected to the CNC bed. So the heights, we just want to make sure stock bottom is offset by a little bit. So onto the passes tab. This option here, whereas previously we've disabled stock to leave, in this case we want to make sure it is still enabled. Doing so means that when it creates those stair steps, the inside corner of that stair step is not going to be at the exact dimension that we have our slope. If we do have that, what can happen is you have sort of very faint ghost lines going around the outside, kind of indicating where that inside corner has just ever so slightly, by maybe like 1/1000th of an inch, gouged into the surface. So by using a stock to leave of 2/100ths of an inch in both the radial and the axial, so axial being the long direction of the cutting bit, radial being the thickness, by leaving a couple 100ths of an inch away from the model, we can still ensure that it's not going to affect the final surface finish. We can do a couple little cheats here as well, where we can do flat area detection. So,
hey Jacob, are you talking about this is the roughing pass still?
Yes, this is
okay.
Still. So flat area detection is going to kind of see that this is a flat area with nothing above it, and it will just kind of machine everything at that level, because there's no need to do like 2-3 passes until you get to that. And the same if we had a little step in here, like a flat section, it would do the same with that. So that's useful. I will disable it though, so it doesn't have to calculate and think about it. You can see here as well, some of the things have moved around slightly. So here where it says the maximum roughing step down. That's going to depend on the radius of your bit, as well as, you know, what your bit material is made of. So carbide bits are going to be probably a little easier to cut through things. If you have a high-speed steel, it's probably fine as well in wood. If this was, say, a smaller piece that you're doing aluminum, if you had a high-speed steel bit, you're probably going to be taking it a bit easier than if you had a carbide bit, for example. So the maximum roughing that we want to do here, I would say, let's keep it at about 3/4 of our bit diameter. So we have a 1/2 inch bit. So let's say 0.375, so 3/8 of an inch. And you see the second setting automatically updates to be 10% of that, and that's the fine step down. So what it'll do is actually do a maximum roughing step where it'll do many layers, and then it'll come back up through those layers that it's created and make smaller steps. In the interest of speeding up the simulation, I'm going to kind of negate that and turn it into like 0.125, like an eighth. So it's only going to be 1/3 of the maximum roughing step down. So basically the finest level of detail that we're going to get here is 1/8 inch layers. And we're going to just check the rest of these, make sure the optimal load that it's ever taking is, you know, you don't really want it to be too low, too high. Around half the cone diameter is pretty good. So this is kind of where we want it. You can also turn on smoothing just to make it output a better path for the CNC. And then we can go into our linking phase on the last tab up here in the adaptive. So because it's a 1/2 inch cutter, the shop butt can go a maximum of 10 degrees ramping angle. But because it's a 1/2 inch, I'm going to kind of go at about 5 degrees, so a little shallower, just so it's not kind of trying to plunge down as fast, as much strain on that. And that's about all I'm going to change in the ramping settings. Just going to check in the passes again, see if there's something that I can see here. This one. So that's good. So I'm going to click OK on that. And as it calculates, you'll see the blue lines start to appear. And everything's looking about right with that. I'm just going to save this so that if anything goes wrong, we have it. So if I look from the side here, you can see it's doing 3/8 inch layers as we told it to. And the processing gets quicker and quicker as it has less and less to have to cut away, has to think about less and less. And you can see here, it's come back in as well and started doing the 1/8 inch layers between those 3/8 inch layers that we told it can do a maximum of. So if we were to simulate this, and to simulate, and then just kind of run that with the stock showing, if I speed that up a bit, you can see that's kind of what it'll be doing. If I kind of get this to something that we can actually see. There we go. That's kind of what it's going to be doing as a roughing pass. And you can see what that does is remove the relevant material that we need to remove, while still leaving us plenty of room where I would assume we have our bolts kind of holding in this big chunk of multi-layer plywood or lumber or whatever kind of beam you're cutting this out of. but you can see it's starting to take shape. If we go transparent, maybe you can see a bit better here what I was saying about the stair-step pattern compared to the surface. So, like that. So they close that simulation and protect. That's what I like to do as well. I like to protect the work path after I've kind of verified that it's correct. So I will protect that so that if I come out of this and come into it again, it will still be a valid work path. It won't have to recalculate that again. It just kind of saves it in the memory of the file, letting it know that that's the way we want it. So with the bulk of that cleared out, what we can do is say we're not changing our tool yet. We're going to still use the flat end mill 1/2 inch cutter and do a horizontal pass. So horizontal is in the menu there, 3D horizontal. What we can actually do, because we're going to use all the same settings again, we can just right click on the adaptive and say create derived operation. And what that's going to do is use the same tool, the same settings, the same geometry, the same machining boundary, and just make sure that all the settings are the same, basically, like the ramping angle, all the rest of it. So create derived operation, 3D milling, horizontal. And say yes, because it's already protected. And you can see it's pulled in the right tool. The geometry is a silhouette offset by the outside. The heights are all the same. It's going to ignore the bottom. Passes, it's smooth. It's basically all good, all what we want. So hit OK on that. And it should just leave this top part here flattened. So you can see it kind of just senses that that's the only horizontal plane that we have in the model, in the file, and it only machines that. So the 3D operations are kind of the smart operations, but you have to limit them and tell them what they can and cannot do. So any questions about that, creating derived paths or anything like that?
Would you want to do this thing that you just showed us with the horizontal before the sloped sides get cut out?
It doesn't necessarily matter. The only reason I've done it before is because for the sloped sides, we're going to change it to a ball nose bit. So it just makes more sense to do the flat surface while we still have a flat bottom bit in there. Cool. So what we can actually do with that, because we're only going to be changing the bit, but we still want to make sure we're using the same surface, the same silhouette and everything, we could come in here and do one of these settings, but we're going to do the same kind of method again, where we just right click, create a derived operation, 3D milling, and we're going to say that we want to do a contour. And say yes again. So before we change any of the settings, we're going to say that the tool we're going to use is different. So we're going to select a different tool. I already have a 3/16 board set up here. Sorry, I'm just seeing Victor comment on the meetup. Yeah, I already have a ball nose mill set up here. If not, you do the same kind of thing again. Click plus, create the new tool, select ball mill, and then set it up depending on whatever the tool that we have is. So again, I'm just going to use this 3/16 one that I've had set up already. In fact, no, I'm definitely not thinking about it. That's too small. What I will do is duplicate it, and then from there, edit it to be a 1/2 inch. And then make sure that it has the right length. So I think the ones we have at SSD in the metal shop are about 3 or 4 inches long. So we have a ball nose bit with a contour path set up. And you can see here, the settings change depending on the kind of operation. So adaptive had its own kind of settings for the geometry tab. Horizontal had very few settings because it's just looking for flat areas to kind of mill flat. And then this contour has settings as well. And what we kind of want to look at when we're using a ball mill is this contact point boundary. So you can see the example that it gives. If we don't do that, it's going to leave a weird little kind of scoop on the bottom. So we want to make sure that actually goes all the way to the base. And then also that we change the stock bottom to be the actual, a bit closer to the base. Maybe like 0.025. So if I click OK on that, we should see it kind of fill in that path because it's already got those settings saved from the previous operations. It's kind of ticking up. You can see it kind of makes some paths around there. And essentially kind of coats the whole surface with a lot of horizontal lines that are all kind of offset by the surface of that ball mill. So if we were to simulate that, and skip through the different tabs, and play from there. So it cleans up that horizontal surface. And then we change out the bit, and it will slowly kind of just essentially spiral down the entire surface. You can see the point of clearing all this out so that the side of this mill doesn't hit material when it's going through. It's only taking off the amount that it needs to get that nice clean finish. If I hide the model, you can start to see the actual finish that it's leaving. It's still a little ridged. But it's, again, it depends on if you want to trade off speed and then just kind of quickly sand it, depending on the final end use of this. I'll speed it up so we can kind of see how it works. But it's saying that this operation here would take 1 hour and 5 minutes, probably a little bit longer. But you'll also see when we get towards the end here, what happens is we have a little red section at the very end of the timeline down here. And what that signifies is that actually it's going to be colliding with some material either too fast, or it's going to be the holder or the non-cutting edge of that bit is going to be colliding with something. And you can see here what it's doing. It's kind of hitting into material that it didn't really want to be hitting into because it's a bit thicker. It's actually around this edge here. It'll go red and we can see where it's hitting. So we look from above. you can tell that if it actually made this move, it would slam into the side of this trough that we created and either stall the machine or damage the bit, break the bit, a bunch of different things. So what we can actually do is kind of go backwards in time, edit the adaptive path, and say that the silhouette we want to do is actually offset by an additional 3/4 of an inch. And that's just going to give it a little bit more room for that ball mill to do its work at the end. So there is a little bit of back and forth with it, but it's kind of important to do that simulation so you don't just run the file and, you know, it does this adaptive cut for an hour and a half, and then the horizontal, and then it does, you know, 55 minutes of the contour path, and then at the very end just breaks or gouges the piece. So I'm going to protect that again. So whereas now, if we were to check on this, I go next to here, you can see when it gets to the end, it no longer has any issues with the collision as it calculates through. So yeah, there's no more red lines, there's no more stopping when it, because it doesn't collide with anything. And you can see it has a bit more space at the bottom to work with. So that kind of highlights as well the importance of using a long enough bit. If you don't have a bit that's long enough, you're going to have to account for the width of the collet and the spindle as well. So you'd have to offset that by, again, pretty much whatever the diameter of that spindle is to make sure you don't accidentally hit anything. So that's one option, is the contour. I will suppress that. And we'll actually try another option where we create a derived operation. And this time it's going to be the morphed spiral. It's one of my favorites is the morphed spiral. So it's kind of similar to the contour, but whereas the contour used kind of tiny layers, this one's just going to be one continuous path, and it will do so, yeah, continuously without steps. So we have 10 minutes of meeting time left. So for the morphed spiral, you can tell it a couple things. You can say we want it to be on the slope. It can only go from any angle between 0 and 90. If you want to operate on something that works between 30 and 45 degrees, that's an option. But because we just want to use it for this whole model, in fact, let's take advantage of that. So let's say we only want it to work on anything that is between 0.1 and 89.9, so that we don't end up milling that top piece. We can also do a similar option, so using the slope command, where we say avoid or touch surfaces. We could say, click on this top surface here and let it avoid that surface instead of touching it. And it will avoid it by like 4/10,000ths of an inch. Then height refine, so we already set that up. Step over. So to make sure you don't get any ridges under the passes tab, what I like to be doing here is on this step over setting, I change that to about 10% of my cutter width. So in this case, it's going to be 5/100ths of an inch instead of, so 1/20th of an inch instead of 1/2 of an inch. And that will allow us to make sure that those little little steps are no bigger than a 20th of an inch. So basically it's going to be less than that because it's a ball. So by the time it gets to that small, it's kind of very easy to sand down. Again, if you wanted very precise, you can let it take a very long time and do like the thickness of a bit of paper. But for our purposes, I think 10 or 11 pieces of paper should be an acceptable kind of thickness step over. This setting here, up, down, milling, if you say don't care, Fusion's going to decide whatever. If you say up milling, it's going to start at the bottom and work its way up. Down milling, it will do the opposite. I'll just say don't care for this case. Outside in, same kind of deal. Clockwise or anti-clockwise, it'll work its way either clockwise around the surface or anti-clockwise. That kind of ties into the direction that our cutter spins. So because we are spinning the cutter clockwise, I like to go around the outside of the surface anti-clockwise. I find it gets a better finish that way. Yeah. So then on the final tab there, on linking, everything there looks fine. So I'll click OK. And it's going to look very similar to the contour path, but what you can actually do is you zoom in and you can see it's actually doing a little bit of a different deal there. It's actually avoiding the top because we told it to avoid that surface. You can probably do a better example if it is allowed to go over that surface. So you can see here, if you zoom right in, it's actually one continuous path the whole time. So if we actually have it avoid that surface, it's going to have little breaks in the path, but the route the path starts to take after, say, this line here is the correct one. So if we were to simulate that, you should see it ends up with a better finish. Hide that model. So it's pretty close. I think we could stand to lower the step over a bit. So under passes, step over, instead of being 0.05, maybe we do go down to 1/100th of an inch. Two sheets of paper thickness. And then kind of see what that looks like in the sim. I think that's going to be a lot better, honestly. Just means that it's tighter kind of lines. Yeah, you can already see at the top here, it starts to be much harder to see those fine lines. To the point where if you had just some like 220 sandpaper, 400, you can just kind of buff those out. See, obviously it takes a lot longer because it's effectively doing 5 times the amount of lines. So this entire process takes 2 hours. Running at our recommended feeds and speeds for these bits. So it's a long time. I get the idea with that. So again, the remaining meeting time is 3 minutes. I'm kind of loath to start the the locating section without refreshing this. So those are a couple of the primary options you could use. There's also other versions here, so like ramp. So whereas we went around the surface with the contour and the spiral, what you can also do is use the half-inch ball to go on these surfaces and do contact point boundary again. And this should go up and down the surface instead of around and around. So as it calculates, maybe I'm just completely incorrect with that. Flat area detection climb. I guess not. Maybe that's just optimized for ramp shapes. The other one is, well, there's a few others, but you can see here they kind of all give good descriptions. Parallel is a good popular one. You can tell it that you actually want to do under the passes. You want it to do both ways and to add an additional pass. And what this will do is do a crisscross pattern across the whole surface with settings that we have set up. So turn smoothing on for that. You can see it does a rough pass there. We'd have to turn down the step over on this as well to be like 0.01 again. And that would kind of do a crisscross over the whole surface, leaving you with a crosshatch. People are going to have to rejoin again. Just let that time out and then rejoin the same link. So the parallel, you can see it just kind of makes a bright blue mess. But what that will actually do in terms of the finished surface is it can give us quite a nice finished effect. And sometimes, well, that's a lot longer in this case because it's doing passes in a perpendicular direction. So because it's doing a pass in both like a sideways and at 90 degrees to each other, it's effectively doing twice as many passes. And what that'll do to the surface, if you kind of zoom in real fine, see it has these lines, and then when it does the secondary pass, not sure if that even translates across Zoom. So it has these kind of horizontal lines, and then when it finishes up the secondary pass, you can probably see at the bottom the little red lines giving across the surface, telling us where we're at. I think it's actually going to be quicker if I turn down the step over. So yeah, what that does is you have a bunch of lines going that way, but then also you kind of take them out by cutting right across 90 degrees. So in doing that, you kind of eliminate any ridges and leave yourself with tiny points. I'm not sure if it comes across, but my computer is whirring with intense thinking. Any questions and comments while that is calculating? Okay. So as this red line at the bottom of the screen kind of gets all the way across to the right, we'll see the finished result. There we go. So when we kind of really zoom into the surface, you can see it has these horizontal lines that have kind of been interrupted with these vertical lines. And that, I mean, we're zoomed in pretty close here. This whole circle's 3 inches. So when you kind of really get down to it, these lines are not big at all, especially in wood. Like I said, when you get down to metals and stuff, you're going to have to do some finishing afterwards, put them in a ball mill or something to kind of take off any burrs. But yeah, that's a couple of the options that we have there. So any questions about that before I kind of step back and go into the multi-layered approach? Yeah, cool. So if we hop back over to design and we kind of go through a couple steps to get back to where we were there. So I just kind of fast forwarded our design history at the bottom there. So we didn't actually delete it or anything. I will hide the original couple of pieces here. So we just have the 4 that have been laid out for us. So we would do these in much the same way. However, we wouldn't really know where they fit together if these were not a symmetrical, rotationally symmetrical object. So if we had one of these that had, say, a cutout in one of them, it's going to be a little harder to orient that in the correct place, as these are different kind of shapes. And maybe even if we kind of just move this circle off to the side, it might give a little bit of a better example. So this has to go together one direction now, right? Because you can see here, it's all kind of sloped towards one edge rather than kind of symmetrically coming up towards the center. I just did that as well by kind of going back into the sketches and editing that. And because it's parametric, it kind of cascades through and updates through all the pieces that I've referenced there. So what we would do in order to locate these is what's someone in Slack. Okay. What would happen there? Because we could stick one dowel in, and that would give us, it'd stop them sliding around, but it would not give us any rotational accuracy. They would just kind of pivot around that dowel. So we need to do at least 2, preferably more, because just the more kind of locators you have, the better it's going to be in terms of rigidity. So I like to go for 3, because then it has 3 points of reference. So what we can do for that, if we kind of go back before we, or after we lofted the shape, I'm gonna make sure those bodies are not hidden parts, except for part 1. After we split it. So we have all these shapes here, and what we need to do is create a sketch on the smaller of our flat surfaces, so that'd be a circle in this case, and just create a couple of circles on here that are the same diameter as locator dowels. So let's just say we're using 1/4 inch dowels, so we use a 1/4 inch hole. We just create 3 of those. Position is kind of arbitrary. Positioning does get important for these when you need to flip it vertically. So if you were doing a 2-sided operation, you would make sure these are about a specific point. So for instance, this point here to the midpoint of this line, we'd use a construction line and make sure that we mirrored this circle and had this one on the line. And the reason we do that is just because then when we flipped it over, we'd ensure that it's in the exact mirrored spot. It's kind of above what we're doing in this session, so just trust that you'd have to flip it about that line, and then that's a way to do it. So we get those circles, and we just kind of select all 3 and extrude them downwards through the whole object. And we can actually just say that we're going to extrude by extent of all, just to make sure it goes through all the objects, and make sure the objects to cut are all of those ones there. And then obviously cut is selectable. Enter to kind of solidify that. And I'm going to hide those sketches, so we just have the holes. And make sure it goes all the way through, which it does. And essentially what we have there is our locator holes for making sure that we have the ability to align those up afterwards. And we just use a 1/4 inch dowel, tap it through, make sure it's in the right spot. Keep getting notifications on. Yeah, no one's waiting. Any kind of questions about that? Or is this on Zoom? Or am I missing something? Okay, so like I said, because it's parametric. We've made that one change there. It's gonna cascade through all of these pieces. So when we lay them out as objects, all the holes are in the right spots. And just make sure that's spaced correctly. So we'll hide these out of the way. And essentially, it's the same kind of deal as we just did for the existing objects as a solid. If we come into manufacture, and before we do that, I want to capture their positions, make sure they don't start wiggling around. So come into manufacture and then get a new setup and say the models we want are these 4. The stock that we have is a 3/4 inch piece, or 3/4 inch height. Oh, this one's laid out a bit weird. So we're going to make sure that's actually laid out in the right spot before we do that. There we go. All I'm doing here is just moving it into place, make sure it's the same level as everything else. So yeah, manufacture, new setup, and select these 4 as the model sources. And then the stock is going to be a fixed size of 3/4 of an inch thick, and say 16 by 48. So we have a piece of MDF, let's say, that we've ripped down to 16 inches wide, 48 long. So, okay to that. So we're going to work in this second setup now. It's going to be much the same, where we will just do a 3D adaptive with a 1/2 inch flat end mill. There we go. And the geometry, the machining boundary is going to be the silhouettes again. The stock contours we're going to leave as they are. And the model bottom, again, just offset that slightly from the bottom so they don't come loose. Say okay to that. We can also mess around with the fine step down as well. And turn on smoothing and a 5-degree ramp. So you can see it just does the same kind of thing again, but as a few different pieces. There you go, just doing the fine step down layers. And as it kind of gets to 100%, it should have all the kind of fine step down layers it needs. And would basically just follow the same kind of excuse me, the same principles again, where we choose our finishing pass using the ball mill. Scallop is a good option because we have these curved surfaces. Additionally, probably before we even do the adaptive, we'd want to make sure we drill these locator holes by doing a drill operation using the appropriate size bit. So for this, it would be 1/4 inch. And as per previous sessions, only use a center cutting bit where the cutters go all the way to the center to do any drilling operations. The kind where the cutters don't go all the way to the center are no good. So we just select the hole.
So we could use like a regular drill bit for that kind of thing?
Yeah, you can use a regular drill bit. You just want to make sure that in the settings that you set up here, you're using an appropriate speed, like 5,000 RPM instead of 18. Because drill bits are not rated to the same kind of speed. So this will go before the adaptive clear. If you ever get any issues like this, you can right click and click generate again. And it will generate the path. So we do the drill operation first, swap out to a larger bit, set our Z height appropriately. It will do the adaptive clearing again. And then from there, I have to let that finish so that it will have settings stored up. But from there, we just do our finishing passes again. We could use scallop, contour, parallel, radial, which just kind of do pretty much straight lines from the outside in or inside out. Morphed spiral. Some of these things have really kind of good examples of what you'd use them for in the illustrations. But where it's just a profile like we have here, usually contour, ramp, or morphed spiral is usually plenty. So you can see this one as well takes a little longer than previous ones because it's having to calculate over 4 different objects. So again, I'll protect that to make sure it doesn't need to be recalculated again. And we'll just do a scallop this time, just so you can see the kind of difference in that. Again, we're going to use a ball mill just to make sure it's going to give us that nice surface finish. And the reason we use a ball mill is because it has essentially a single tiny point of contact instead of with the flat mill, it would have kind of the whole rim. Contact point boundary again, and make sure the height is set a little bit lower again. And then the passes are set up to incorporate smoothing and say okay to that. So you can probably tell this takes a little bit longer, but that's one of the reasons I like to use the morphed spiral operation. It's just because it basically projects a spiral from above until it hits the surface and then uses that as the toolpath. So it's a bit quicker to calculate than some of these other ones. So if we were to simulate this, we have a board here, let's say, and straight away it says it's colliding. So we'll turn that off because it's just drilling instead of cutting. So it counts that as a collision. So hide that model, speed this up. I've seen this before, but you can see it just kind of comes through and does all those. So it gets to here. And this is when we kind of swap out into our ball nose bit once we had these parts. And yeah, essentially just kind of comes in and cleans up the surface like we have done 5 or 6 times before this. kind of skip towards the end. I suppose it's a good example here. We wouldn't want this to be using the scallop on the top surface here, simply because we want that to be flat, the same with all the rest of these. So that's an example where we would actually edit that and say we want it to, in the geometry, avoid touching these surfaces, because we need them flat to be able to glue together. And just going to suppress that because we don't really need that one. That really about kind of is the meat of how you would do a 3D operation.
What do you click to make it run the demo?
Sorry?
What do you click to make it run the demo?
So if you wanted to run the whole demo, you click on the entire setup and then up here, the actions simulate. If you want to just do a particular one, like for instance, it's radial, then you can just select that option and then click simulate, and it will only do that. But you can see it doesn't have any of the previous steps that it would normally have, like the clearing operation. See, something is wrong there. It's not doing the whole thing. So I don't use radial that often, so I'm not very up on how it actually goes. Okay, so the outer limit would need that to be pretty much our entire board. So it would be half of whatever the board length is going to be, like 48. I guess in this case, actually, you'd want to do several different operations of this radial thing. So under geometry, you'd say model, and then have it only do, don't include the setup model, and only include this one. And then duplicate that for each individual one. So example like that. And the going from the center of the stock. So there's just different kind of finishes you'd get using these different things. Generally, if you just want one that's going to work, parallel or contour is pretty much a safe bet as a finishing pass. I think that's about it, really, guys. It's you can tell in terms of calculation, it gets a little bit more intense when you start doing 3D stuff. So radial is an operation you only want to use when your object is centered around the middle of the stock, because you can see here it did a good job, but here less good because it's further away from the center. So that's kind of two ways to make what would essentially be this object. So, any questions for anyone? Anything that is clear as mud?
Oh, this was really helpful. Thanks, man.
Well, you're welcome. Like I said, sorry about the kind of interruptions on the Zoom side of things. Yeah, I'll have to look into how much it costs to do all the professional package, and have I'll try and have that looked into before Wednesday, Brandon, for your part 2 CNC class.
Oh, that'd be great. Thanks.
Yeah, because then you can log into the SSD one and yeah, do it that way.
Yeah.
But yeah, I mean, unless there's any kind of queries or anything you want me to quickly cover outside of the kind of aim of today.
Thank you.
Yeah, thank you.
Did that kind of hit the spot for you, Tucker? It was kind of you that asked about sloped surfaces and.
Yeah, that was really helpful. I'm gonna have to probably watch some of this again. I think the thing that I'm gonna find challenging is just setting up like the tool paths and all that, like setting it up to communicate. I think I can build the model without too much trouble. It's just getting in the machining to happen the way I want it to, I think might be a little more difficult.
Yeah, I guess the key takeaways are, you know, you have your model, you want to do setup, select the model you're going to be using, make sure the stock is set up in the correct size for the piece that you actually have, and that your model is offset from the bottom of that by pretty much 0. And then from there, adaptive clear under 3D.
And if you were to do like the bottom of that, say you wanted to hollow out the bottom of that with like, I don't know, an inch thickness or something, would you just run a whole new program and just set it up so that your like 0 point on the machine is in the same spot or something? Or how would you go about doing that?
I'm going to make a simpler thing than this weird curve piece real. I'll be quick about it. So,
I understand that would be difficult to flip upside down and keep stable and everything. I'm just like you don't have to go through the whole process. I'm just like generally speaking, is that how you would do it?
Yeah, so you just kind of have your object, you know, you'd have your, yeah, pretty much. You need to do that. You'd flip it upside down, have your locating holes. So for this, if I were to turn this into a 3D sketch, I can actually come over to the side and get this and move it upwards or downwards. And from above, you'd have your locating holes, like I said, in a single spot there, and also you basically have an arbitrary center line that you'd use. And it's important to have that so you can then use the mirror function, mirror about the center. So those are spaced equally from the center line of this piece, right? You can then do what we did before, where you loft the bottom to the top. Say okay for that. Extrude the holes through the surface all the way. Distance ball. Hide the sketch. So you have this object. The holes kind of go all the way through it, right? So what you'd actually do under manufacture is make sure that the sketch line that we had in the middle here is our origin. So when we make a new setup for this, we would, where it says stock point here, we'd change the origin to selected point and would use this line. Okay. And
Yes.
then the important part there as well, making sure it's the same thickness, is, like I said, I did it 1 inch, right? Is when we, with the origin at that line, so it's on the top surface in the center of that line. If this side-to-side direction here is our x-axis, we need to make sure that when you do the second operation, you flip it over on that same axis. So this hole would go into this hole. And in order to do so, you would do a drill operation through these holes, and under heights, on the whole bottom height, you want to drill through the bottom and go maybe like 3/8 of an inch, and you're actually going to drill into the CNC bed. Or
What does that break through? What is it?
Drill tip through bottom.
Okay.
A better option than drilling into the CNC bed is to put a sheet of MDF down and then drill through into that. But the machine will do the drilling basically, so that's in a precise location. So if you look from the front here, you can see it comes all the way through. We actually use the right size bit, so 1/4 inch bit. So it comes all the way through, and you would use little dowels into the holes that it creates. So you'd machine this as normal, right? We do like adaptive with the 1/2 inch bit and everything, right? So you'd machine it as normal, and then you'd flip it over in a second setup. So if we duplicate this setup we just made, and you just kind of edit that setup and click the little tip of the Z arrow, you can see it flips, but it's flipping the y-axis. You want to make sure that we flip the x-axis and keep that y-axis the same, right? So what's actually happened is now the up direction is basically downwards, and the x direction is the other way. So from there, we can then actually say OK to that, and then we'd do whatever operations on the inside, right? So we'd maybe hollow this out. We'd have to have that modeled in, obviously, under design. So, you know, you shell this surface.
That all makes sense. So it's just kind of, you don't have to hollow the whole thing out. I was just asking sort of generally.
But that's the way to do it. You need a center line, and you need to have the locating dowels be exactly symmetrical about that center line, and make sure that your 0 for the machine in the X and Y, or at least in the X, is on that line. So when you flip the piece over, you're still using the same coordinates, just in reverse.
Thank you.
There's videos about it on YouTube that are going to do a better job than I've done in that like 5 minutes. But yeah, that's kind of the gist of it.
It's helpful. Thanks.
And you mentioned the stuff on my website before. That's exactly how I do the spiral things. I have 4 locator pins, and then make sure that the center, the origin, is exactly in the middle of all of those. And then when I do the bottom side, I'll flip it over, do the top side, and then kind of plug those holes with dowels and finish it with a solid piece of wood. So you never even kind of know that they were there. But it looks like we have less than a minute left, so I think I'll call it there, if that's okay with everyone.
Thank you.
Thank you.
Yeah, thanks.
Thanks for attending. Bye-bye all,
Hope you have a nice evening.
and you. Bye-bye.